All right, so a couple more examples. This is a pretty interesting one, actually. We have an arithmetic sequence or series, I suppose, because it says S7. And we do not know D, we do not know U1, we do not know UN. So here now, we know that, for example, S7 is going to be 7 over 2 U1 plus UN, but we don't know what UN is. We also, that's for this one here, we also know that U5, 19, is U1 plus D onto 5 minus 1. So that tells us that 19 is U1 plus 4D. And this one here, S7, is 98. So 98 equals 7 over 2 U1 plus UN. Okay, that's all well and fine, but we have 1, 2, 3 unknowns here. We're in a little bit of a pickle. Now, what we can do is use the other form of this formula here. Or we can derive it by just substituting in what UN is. That's what I'm going to do. 98 is 7 halves U1 plus UN is U1 plus D onto n minus 1. So we have 98 is 7 halves 2U1 plus D onto n minus 1. N here is 7, so that's 6D. Okay, so I've taken all the information I have, and I've just gone straight forward by plugging it into the formulas I have, okay? This obviously is a sum, it's going to be the sum formula. This obviously is a general term, it's going to be the general term formula. It's arithmetic, I'm using the right formulas. All I've done is I've taken the information I have, and I've plugged it in. What have I ended up with? Well, I've ended up with an equation here with a U1 and a D, unknown. And an equation here with a U1 and a D, unknown. What do we do? Two equations, two unknowns. System of equations. Okay, so for this system, I mean, there's a few ways I could solve it. First, let's clean this up a little bit. This is a 3.5. I'm going to divide both sides by 3.5. 98 divided by 3.5 is 28. Okay, so this is 28 equals 2U1 plus 6D. And I have 19 equals U1 plus 4D. How would I like to solve this system? I know a lot of you would like to take this and say, oh, U1 equals 19 minus 4D, and then substitute that right here and solve. And that's a totally legitimate approach. That's called substitution. I actually like elimination when I can do it. So I'm going to do that method. I'm going to multiply this second equation by 2. 19 times 2, that's 38. U1 times 2, that's 2U1. 4D times 2, that's 8D. And now I can subtract my equations. I'm going to subtract the second one minus the first. 8D minus 6D is 2D. 2U1 minus 2U1 is 0. 38 minus 28 is 10. Divide both sides by 2, I get that D equals 5. Wonderful. Now that I know that D is 5, I can plug that back into either equation. I'll take the equation 19 equals u1 plus 4d, because that's an easy one to work with. And I can solve for u1. So I'll plug this 5 in here. Now I get that 19 equals u1 plus 20. Subtract 20 on both sides, I get negative 1 is u1. Okay, now I have all the pieces for this arithmetic series. Okay, so I know that u1 is negative 1. I know that d is 5. Let's just list out all the information I have here. u1 is negative 1. D is 5. I know that U5 is 19. And I know that S7 is 98. And what the question really asks for is to find UN, the general term. Easy now. UN equals U1 plus D onto n minus 1. I know U1, I know D, so UN equals negative 1 plus 5 onto n minus 1. Now you might see this rearranged. I think I will. UN is negative 1 plus 5n minus 5. So UN equals 5n minus 6. There we have it. Okay? So that's a nice question, actually, and it's not so obvious right off the bat how it's going to go. The key is there's only one formula that can accommodate this, and there's only one formula that can accommodate this. And because one is U5, term 5, and the other one is S7, we can't also easily just figure out D directly. And so each one goes into its appropriate formula. And we notice at a certain point, we've got two equations with three unknowns. That's a problem. U1, UN, U1, and D. And so then we change the form so that we end up with two equations with two unknowns, and from there we're away to the races. You may like to take your preferred method here, those of you who do prefer it, substitute it in and see if you get the same value. You should, of course. All right. So the last question here is going to be a graphing calculator is okay on this question. For the series 4 plus 16 plus 64 and so on, what is the minimum number of terms required for this sum to exceed 10,000? Okay. So what's being asked here? Well, we're saying for what value of n is Sn greater than 10,000? Well, Sn is what? Let's see here. This is geometric. I'm multiplying by 4. I'm multiplying by 4. My common ratio is 4. And it's geometric. So I have that Sn equals U1, 1 minus r to the n over 1 minus r. And I want that to be greater than 10,000. R is 4. U1 is also 4. So I have 4 onto 1 minus 4 to the n over 1 minus 4 has to be greater than 1,000. Okay? This is a GDC okay. So, I mean, I could simplify this a little further. Maybe I will. Or I could just go and just plunk this right into my graphing calculator. Let's just do that. So, in my graphing calculator then, I'm going to type in this fraction. Now, I've got to be careful. This numerator and this denominator, they have to be in brackets with a division in between them. Unless I were to simplify first, but I'm not going to do that. So, I have, let's see here. That's not bad. Okay, so I'm going to go into y equals mode. Oh, shoot, I changed the window. I didn't intend to do that. So let's put this back the way it was. There, that's reasonable. So I'm going to have to do 4 onto 1 minus 4 to the n divided by 1 minus 4. That's what I want to graph, and I want to see when is greater than 10,000. Okay, so I'm going to go bracket for the numerator, 4 times bracket 1 minus 4 to the exponent, there's the little caret, n, or x, okay, and I'll push the right button so that it comes in the right spot and I can close that bracket, and then I'll close the bracket again so that that's my numerator, divided by bracket 1 minus 4 bracket. Okay, and this will be the graph that I want. So that is this, which I'll call y1. And now let's also graph 10,000, which will be y2. Okay, so into y2 here, how do I do that? I'll push down. Here we are. y2 equals 10,000. Enter. Okay. So now if I just graph this, I have my graph coming along and it turns up. Okay, great. It's an exponential. But I don't really see where it crosses 10,000. So I'm going to have to change my window. I go into my window. And what are my window settings? Oh, can I not change my window? I'd be very disappointed. Oh, here we go. It's just a little bit slow. So you can see it's obviously not going to be a negative. Let's just go from a min of 0. Max, I don't know. Now, if you actually look at the table, which you can see right away, you can see that at step 9, we're 349,000. And I'm trying to get bigger than 10,000. So a max of 10 is fine. My min, let's go from, I don't know, maybe 9,000 up to 10,000. Let's see how that goes. I want to be bigger than 10,000, so let's get 11,000. Whoops. There's 11,000. Now we'll graph and let's see what we get. So this can take a minute to plot. There it is. And then my 10,000, y2 equals 10,000. Here it comes. Now I want to see, where is this intersection point? At what value of n does the left-hand side in blue cross the right-hand side? So I'll go second calc intersect. First curve, where is my cursor? It looks like I'm on the blue line, enter. Second curve, I'm definitely on the red line, enter. Guess, I'll get a little closer. Okay, that's nice and close. Enter. And it thinks for a second, and there we have it. We have x equals 6.4364 and y equals 10,000. So then if I come back to my question, for what n do we first exceed 10,000? Well, the answer would be 7. Okay. Whoops. So we have that to exceed 10,000, we need 7 terms. Whoops. Okay, and if I wanted to do a little check, I could just throw 7 in and calculate it. I suppose we could do that, or we could even just look at the GDC and we could say, okay, let's look at our table then. In the table, we have that at 7, we're at 21,844. That's the first time that we exceeded 10,000. Okay. So this gives enough. This gives us enough now that you should be able to tackle all the questions in exercises 1I, exercises 1I, 1J, and 1K.